Okay, I'm using the same file here to flip through so that you remind yourself of the pieces that you have to pull together to understand El Nino. Walker cell, normal conditions, the changes that happen with ENSO, El Nino Southern Oscillation, and how the ENSO conditions look in terms of sea surface temperatures, convection, and the perturbed Walker cell. You can see that the normal Walker cell has rising motion in the west and sinking motion in the east, but during a full-blown strong ENSO condition. Why do I say strong ENSO? Because sometimes the sloshing of the warm waters doesn't happen all the way to the east coast, and the warming in the east is not always as strong, and we will see some of the strongest El Ninos or ENSOs that happened that created very warm conditions in the east and anomalously colder conditions in the west. So the strength of the El Nino and ENSO can be different. Okay, so the perturbed Walker cell here, convection has moved to the east, which means the rising motion and the convergence are now happening in the east, and the air is again hitting the ceiling and it is going westward. Before we looked at the eastward flow associated with the normal Walker cell. In the perturbed Walker cell, you have this westward anomalous flow and sinking over the West Pacific. The rainfall doesn't completely disappear in the west because it is still pretty warm. There is reduced rainfall, which means reduced rising air, so the anomalous circulation will be sinking. How do you do anomalies? Basically, you take the El Nino condition and you subtract the normal condition from it, and you look at the difference, how El Nino condition looks different from the normal condition. So it is this difference that we call anomaly, and here is a good example of how we do it. What is being shown here is the sea surface temperature anomaly. Okay, so the mean temperatures can still be colder here and warmer in the west, but the west will be much cooler than normal, and the east can be much warmer than normal. Remember, it's at 23 degrees centigrade when it's normal. So even a 5-degree warming of the El Nino can make it 28 degrees, whereas the cooling here can be just about 1 degree, so it may go from 30 or 29 to 28 degrees. So you still have to remember the total sea surface temperatures. These are anomalies. Okay, so the anomaly looks like this. Entire eastern coast of the Pacific, so the west coast of the US all the way into Alaska, and the South American coast all the way down to Patagonia and so on, can become much warmer depending on how strong the El Nino is. So this warm anomaly is very strong here. This is from one of the strongest El Ninos of the time in 97-98. But if you Google, you will see that not all El Ninos get this strong, and there are also lots of details on how El Nino is changing because of global warming, whether the East Pacific is warming more than the West Pacific or less, and so on and so forth. That debate goes into a very detailed discussion on where the ocean is taking up heat and whether it's continuing to take up heat or it's taking up less heat and so on. What do we mean? If there is upwelling in the east and the ocean is heating the ocean, if the atmosphere is heating the ocean, that means the ocean is soaking up the heat from the atmosphere like a sponge. Remember, we said ocean takes up more than 90% of the excess energy during global warming. This East Pacific is one of the largest regions where the ocean is soaking up this heat. So how the East Pacific responds to global warming determines whether the ocean will continue to take up just as much heat or not. Okay, slightly different issue than El Nino, because El Nino is natural variability. It happens every few years. But if global warming affects the sea surface temperatures and the east-west gradient, then the El Nino behavior, ENSO behavior can also change. That's a critical question. We don't understand everything about it. It's a very active research area, but you can Google and learn more about it. Okay? So we will try to learn about the other part of this story called La Nina, but we will also see what impacts El Nino has. I kept mentioning impacts. We'll look at one map which shows the impacts, but again, you can Google and there is lots and lots of material about El Nino tribes, a lot of institutions maintain El Nino websites, El Nino watches, El Nino forecasts, and so on. Okay, very important topic. Follow it up.